Okay, so let's look at some of these molecules and write their chemical formula. Okay, first of all, number 1, lead 2 chloride. So lead has a Roman numeral 2 there. That means it is lead plus 2. So that means this lead has a plus 2 charge. And we know that chloride, when it's in an ionic compound, is going to have a minus 1 charge. So we cannot simply put this as a chemical formula because this is a plus 2 and this is a negative 1. If you add those two numbers, that is a plus 1 charge. Nature likes things to be a 0 charge if possible. So how can we make this whole thing into a 0 charge? We can only add either lead or chlorine atoms. So we need to add 2 chlorine atoms. So that chlorine now will be a minus 2 charge because there are now 2 chlorine atoms. So we write the formula as such. So we will write it 1 lead and then 2 chlorine atoms. So now this is a plus 2 charge. This is a minus 1 times 2. That's a negative 2 plus 2 plus a negative 2. This whole thing then is equal to have a 0 charge or a neutral charge. So this is the chemical formula for lead 2 chloride. For the next molecule, we have magnesium phosphate. So magnesium has a plus 2 charge when it is in an ionic compound, and phosphate, looking at our polyatomic anion table, phosphate has a minus 3 charge. Again, we cannot just simply put magnesium and phosphate together because this does not equal a 0 total charge. This is a plus 2. This whole thing here is a minus 3. That means that as this is written, it has a negative 1 charge. So this is not going to be the correct chemical formula. To make a 0 or neutral chemical formula, we will need 3 of these and 2 of these, so that this will be a magnesium will have a positive 6 charge and the phosphates will have a negative 6 charge, and if you add this and this together you get 0. So we need 3 of these and 2 of these. So this then is the right chemical formula for magnesium phosphate. Looking at number 3, sodium hydrogen sulfate. So sodium has a plus 1 charge in an ionic compound, and hydrogen sulfate, we know that sulfate has a minus 2 charge. If you add a hydrogen to this, that becomes a negative 1 charge. So hydrogen sulfate is a negative 1. Since this is a positive 1 and this is a negative 1, and if you add it together, it becomes 0, that means all we need is what is written. So 1 sodium and 1 hydrogen sulfate. So the correct chemical formula is this for sodium hydrogen sulfate. For the next one, number 4, we have barium sulfide. Barium is a plus 2 charge, and sulfide is a minus 2 charge. So plus 2 minus 2, add these together, you get 0. So that means we just have this is correct, 1 barium atom and 1 sulfur atom. So this then is the chemical formula for barium sulfide. Looking at number 5, we have calcium nitride. Calcium is a plus 2 charge. Nitride is a minus 3 charge. So again, we cannot just have 1 atom of this and 1 atom of this because the overall net charge will be a negative 1, so this cannot be. So we need to take 3, we need to have 3 calciums and 2 nitrogen atoms, so that If we do that, then we have a plus 6 here and a minus 6 here. Like I said, if we have times 3 here and times 2 here. So we need 3 calciums and 2 nitrogens, so that this is add up to a net value of 0. Again, another way you can actually do number 5 is like this. This may be simpler for some students. Again, since this is a plus 2 charge here and nitrogen is a minus 3 charge here, what they do is just put the 3 down here and put the 2 here, so it looks like this. This is a good thing to do if you're running out of time on a quiz. Again, it's obviously the same answer, but this is just a faster way of getting to your answer. Same as this. Okay, so going ahead to number 6, we have tin 4 oxide. So tin, because of the Roman numeral 4, that means this is a plus 4 charge here. Oxygen is a minus 2 charge, so we need 2 atoms of oxygen, so that this will be a minus 4, because plus 4 plus a negative 4 is equal to 0, so we need 2 oxygens, so there it is. That is the chemical formula for tin 4 oxide. Okay, looking at number 7, we have aluminum selenate. Aluminum is a plus 3 charge. Selenate is going to be similar to sulfate, since they're in the same group. Again, sulfate was SO4 2 minus, so selenate must be SeO4 2 minus. Se4, which is a minus 2. So then, again, let's just do it the easy way. It's better if I wrote it this way. This is a plus 3, this is a minus 2. So you could just put the 2 down here and the 3 over here. So you'll have aluminum and then SeO4 3. Again, this is a simple way to do it, but it makes sense. Again, aluminum is a plus 3, you have 2 of them, so times 2, this becomes a plus 6 charge over in the aluminum side. Selenate is a plus 2 charge, but you have 3 of this times 3. This is a minus 2 charge here. Minus 2 charge times 3 is a minus 6, and this plus this is equal to 0. And the last one, beryllium hypochlorite. So beryllium is a plus 2 charge, and hypochlorite is ClO minus 1. So we need 2 polyatomic of the hypochlorite. We need 2 of those, so that this will now be a minus 2 charge, and then that'll give us a neutral species. So again, we need 2 of the hypochlorites. So then this is the chemical formula for beryllium hypochlorite.